All right, so we're going to take the derivative of an integral. So we're going to have to use the fundamental theorem of calculus. So since I'm taking the derivative of an integral, I have to make sure that the bottom's a constant, which it is, so that checks. My variables match, which they don't, but because they are the same variable, all I have to do is multiply by the derivative. So derivative of 4x is 4. So there's the derivative. So the integrals cancel, and then I just have to substitute that for the t. So I'm going to have cosine of 4x plus 4x squared. So 4 cosine 4x plus 16x squared. For b, I'm also taking the derivative of an integral. The problem is that my bottom number, my lower limit, is not a constant. So what I'm going to do is I'm going to make it into a constant. I'm going to assume that x is smaller than x squared, and I know between there's a constant. So I'm going to break this apart into two integrals. So I'm going to have from x to c of t minus 1 dt, and I'm going to add from c to x squared of t minus 1 dt. So I broke it apart, and I'm going to take the derivative of each integral. So the derivative of the first one, before I can do this, because I need the constant to be on the bottom, so I'm going to make it into a negative. Okay, so I'm taking the derivative of an integral, lower limit's constant, upper limit matches the variable, so they cancel, substitute. So I'm going to have negative x minus 1. Okay, here they don't match, but the rule says I can take the multiply by the derivative and then substitute inside. So my answer is going to be negative x plus 1 plus 2x cubed minus 2x, or 2x cubed minus 3x plus 1. For 22, I'm just going to take the antiderivative. So remember the shortcut when you have a linear term is when we would use the chain rule and we would take the derivative, we would multiply. For this, we would divide by the derivative. So the derivative of 3x is 3. So we're dividing. The antiderivative of cosine is positive sine. And I'm going from 0 to pi over 2. So I'm going to have 1/3 sine 3 times pi over 2 minus sine of 0. So 1/3 times sine of 3 pi over 2 minus sine of 0. Okay, so 3 pi over 2, right, is pi and 1/2, so pi and a half. And this is 0, negative 1. So sine of 3 pi over 2 is negative 1. Sine of 0 is 0. So I get negative 1/2. 23, you find the antiderivative of x squared root of x. So once again, you try to do algebraic method that you can't. If you do use substitution, nothing's going to cancel. So I'm going to have to do integration by parts. So I'm going to let u be something and dv be something else. So one of the things about this is that I do have two polynomials instead of, or two polynomials. So I'm going to have u be x and dv be x squared plus 2, or actually one polynomial and one square root. Okay, so I'm going to use U substitution, and I'm going to be able to do the table. So I'm going to have x, 1, 0. Okay, so this one is a little bit more trickier because within integration by parts, you're going to do U substitution to find the derivative. Okay, so you're going to have U to the 1/2 du. So the antiderivative of U to the 1/2, if you add 1, is U to the 3/2 multiply by the reciprocal. So this is going to be 2/3 U plus, x plus 2 to the 3/2. Okay, so now you're going to take that derivative of this. So same thing. So you're going to add 1. So now you're going to have 5/2 divide by the reciprocal. I'm sorry, divide by 5/2 or multiply by the reciprocal. So I'm going to have 4/15 x plus 2 to the 3/2. Okay, so now I'm going to have plus, minus, plus. So my answer is going to be 2/3 x times x plus 2 to the 3/2 plus or minus 4/15 x plus 2 to the 5/2 plus c. Okay, the graph of the function f is shown below. Let the graph be given by g of x. Okay, find g for, okay, so let's do this. So g of 4 is going to be 0 to 4. What I'm doing is wherever I see an x, I'm substituting a 4. So what this means is find the area under the curve of f from 0 to 4. Okay. So I'm finding the area under the curve. So different ways I can do this. I can do this. So here's a triangle. So it's going to be 1/2 the base times the height. Okay. This is a trapezoid, so I'm going to use the trapezoid. So trapezoid is base 1 plus base 2 times the height divided by 2. So I'm going to have 12 divided by 2, which is 6. And then 6 times 1 is 6. 6 divided by 2 is 3. So g of 4 is 9. Okay. In order to find g prime of 4, I'm going to have to use the definition first. So g prime of x is we're taking the derivative of an integral. So that's using the fundamental theorem of calculus. So notice we have a constant on the lower limit. The upper limit matches. So that means this is going to cancel. And I can just substitute the x for the t. So what this means is find the point at 4. What is my y value when x is 4? So when x is 4, my y value is 2. And then once again, to find the second derivative, I'm going to take the derivative of the right side. So this means find the derivative of f at 4. So that just means find the slope of the line. So the slope is rise over run. So my slope is negative 4 over 2 or negative 2. And then the last question says, Does a relative maximum occur at x equals to 3? So at x equals to 3, do I have a relative maximum? The answer is no. Why? Because remember, since g is defined as the integral of f of x, we are looking at the derivative of our function. Okay, so this is our derivative. So the maximum occurs at the 0. Okay, so this would be no because a max or min occur when g prime of x is equal to 0. Okay, so that's going to happen here or there.